This is problem 498, diagonal traverse. It's a medium problem given an n by n matrix. M by n there doesn't specify if it's odd or even. Return an array of all the elements on the array in diagonal order. And then that's pretty much all you're given. They can be, M and n can be one each. The multiplication of them must be less than or equal to 2. Was that 10,000? Each value can be, each element in the matrix can be positive or negative. So if you start here 1, if there was another element here, it would have went here, but because it's not, then it bounces back to go here. Then it goes to 2, 4. If there was something here, it would go there, but since it's not there, it just bounces and hits here, and then so on. So if we have an example, 1, 2, 3, 4, 5, 6, 7, 8, and 9, then you're going to go 1, then 2, 4, then 7, 5, 3, then 6, 8, and then the 9. Let's see. So let's say you had, so here it's M and N are the same, 3 by 3. So let's say you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in this case, you would start the 1, then you would go to the right, you hit 2 and 5, then you would go down 9, 6, and 3. Then now here, do we go down to 7 or go right to 4? According to this diagram, it looks like you hit up, bounce back, so it looks like it hits the 4, not goes down to the 7. So it looks like it would be 4, 7, 10, then bounce this way, it goes to the 11 and 8, and then 12. And let's do one more example where this time you have more rows than columns. So 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, you go 1, then 2, 4, then 7, 5, 3, then go down 6, 8, 10, then 6, 8, 10. So you would go down, but there's nothing there, so you have to go to 11 and 9, and then the 12. Okay, so some things we notice is 0. This is 0, 0, so that's why it would. So if you notice, this is index 0, 0. This is 0, 1, and then 1, 0, and then 2, 0, 1, 1, and then 0, 2. So you know that just based on that, we know that I plus j even, then upright I plus j is odd, then you go here, you go down to the left. The exceptions would be, so this is odd, even, then here this is so this is an odd, this is index or row 0 column 1 is odd, 1 row 1 column 0, but then you can't go down left. So in this case here column is 0, if C equals 0, then instead of going down to the left, you go just down. So it will go to the 9. Yeah, 1, 2, 5, and then the 9. So you just go I plus equals to 1. And then let's see. down here, 5 here, 963, then 4, 7, 10. So again, here, this is going down to the left again, but now here, row is the last row. So then another condition we have if r equals length of mat minus 1. So in this case, 4, 7, 10, you can't go here, so then you go to the right, so 11. So then in this case, you have j plus equals to 1. And then 8, so this is row 2, column 2, so that's even. 11, 8, and then 12. So let's see. Now let's go 0, 0. We're only going to look at the odds for now. So you're going down right here. C equals 0, so then you go down. So we already have that. 7, 5, 3. 6, 8, 10. Row hits the last row, so then you increase J. So yeah, so you went 6, 8, 10, and then the 11. Okay, so this should cover everything for the odd, and even is probably just going to be the opposite. If R is 0, increase J. If column is mat of the very right column, then you increase I. Then you go upright. So let's just confirm that. So these are the even ones here. No, this is the even. So here, 0, 0, you go to the right because, row is 0, so then you go to the right. Then this is odd, then even, upright, upright. Here, R is 0, so then go J plus 1. But here, you can't go J plus 1. So here, you have C equals. So this should take precedence. This should come first. Because in this case, you hit both the first row and the final column. So in that case, you want to go down instead of going to the right. And probably the same thing applies here. So if you hit the first column, but the last row, while going down left. So let's see here. So this goes 1, 2, 4, 7, 5, 3, 6, 8, 10. So 10 here. This is the last row, the first column. So you're not going to go down, you're going to the right. So that's why this should come first. So here, J plus 1. Yeah, so this should take care of everything. And we're pretty much done when we hit the very last row and last column. Okay, so now we can code this. So let's have big R and big C equals the total number of rows and columns. I and J will both start from 0 and 0. And while true, so if I plus J is odd, okay, so if it's R equals the very last row, so that'd be R minus 1, then you increase J. Otherwise, if, so this should be I. And then if J is 0, then you increase I. Otherwise, you go down left, so that would be I plus equals to 1, and then J minus equals to 1. And then here else, if J equals the last column, so that would be C minus 1, then you increase the row. Here, if the row of 0, then you go to the right, and then otherwise you go upright. So that would be I minus equals to 1, J plus equals to 1. We need a variable res to store the list of values. So let's see. So you gotta first add the value at the given index to res. And then here, so basically, if I equals R minus 1 and J equals C minus 1, then you're done. Turn res. Otherwise, you go through all this. Oh, and then, yeah, so we append res, and then, yeah, so that should be everything. And it passes all test cases. So yeah, thanks for watching this video, and see you next time.